Hello, so welcome to this lecture video. This is about topic overview for actual exam P1. For this topic today, this topic is two-variable continuous distribution. So for two-variable continuous distribution, the density function is a continuous variable, a continuous function, density function. So once we have density function, so we have like a marginal density function is just the, let's say marginal density function for both of them x, y. Okay, so marginal only for x, so we just fix x, so we just check all the y, right? So if the marginal density function for y, so like for if y fixed, then x just is up, right? So there's marginal. And the conditional density function is if we fix the y equal y. Okay, so y equal y. So we just check those points. Okay, so density function is just like fxy, but this y is fixed. Okay, suppose y equal y0, y is fixed. But this, when y is fixed, this maybe is not a density function, because like we add those x together, so this add this x together, maybe this not equal 0, right? Or not equal 1. So we need to use some constant, so we can regard this constant. So totally like a total total probabilities, just those probabilities for fixed y, just all the total probability. So this is the marginal density function for y, right? Okay, so for expectation, so we say expectation for, we have this expecting for this just this double integration of this density function. So maybe not, so this integration upper bound lower bound maybe not from negative infinity to positive infinity. We just say like just in this region, so gxy, so fxy dx dy. So this region D is those functions not equal 0, right? So typically the correlation is this formula. Okay, correlation is xy minus x times y. Okay, so let's check some problems. So we say most problems just like a double, essentially just a double integration problem. Like for this one, suppose we have this joint density function thus, saying we want to find the probability for what? So still functioning 20 months from now. So this means like so this is x, this is y. Okay, so we want to find this probability that both of them still functioning 20 months. So means x larger than, so here's 20 x, so 20 and this y 20. So maybe this part, right? So x, both of them, x larger than 20, y also larger than 20. So we just do this integration. Suppose this is d. So we just, this probability is just this, right? Density function, this d. So dx dy. So those just a double integration. Okay? So we just find this d. Right? So this d, let's say, this d is, okay, the continuous this. So this, let's say the x plus y equal 50. So x plus y equal 50, maybe like this. x plus y equal 50, and also so here so x larger than equal 50. So just this triangle, right? Yeah. Okay. So we say this these. So x. So start from 20 to 50. Oh, not 20 to 50, just to this. So we just check this point. So this point y is 20, so x equals 30. So just from 20 to 30 dx, right? And then dy, y from 20, so this y is 50 minus x. Okay, so then if xy dx dy, dy. Okay. So this is just a double integration. Okay. So for this problem, find the covariance. At first we say covariance equal xy, so minus x times y. So here we need those double integrations. So let's say like for x, what is x? So x just equals this integration, this region, right? So x if xy, not dx dy. So y just change this. So y is just this, right? dy if xy. Okay, so dx dy. And what is xy? So xy so equals this. xy if xy dx dy. So this is just the definition. So if we wanted to find those result of, if we wanted to do the integration, so let's check. Okay, check this. So and this the d, the region the x between 0 to 1. Okay, so y, so 0, so suppose this x, this y, so between 0 to 1, and y is also from 0 to 1. Okay, so this region D is this square. Okay, and we don't know this k. So at the first maybe we need to find this k. So let's say this k. So with the total integration is equal 1. So let's say kx dx dy. This equal 1. Okay, so we can find x. We can find k equal. So this integration is just x from 0 to 1, y is from 0 to 1. So x, so kx dx from, so just becomes this 0 1 kx dx equal 1. So we find k equal 2. Okay, so k equal 2. So by now those integration really easy, right? So for example, find this. So we say x equals 0 to 1 dx, and then y is also 0 to 1. So this from x y. So k f x y is kx is 2x. So dy. So for this integration is very easy. We put x. Okay, dx. The dx here is 2x squared dx, and then here dy from 0 to 1 dy, so just half. Yeah. Okay. So this just equal 1 over 3, like 1 over 0 to 1, then x squared dx. So this equal 1 over 3. Okay, so such a problem is just an integration problem. So we should do quickly. Okay, so for this one, let's say the same problem. But here the integration, the region is thus x from 0 to 1, y from y equal x, or y equal 2x. So here's y equal x, y equal 2x. Okay, so 0 to 1. So the region is this part. So let's say find the covariance. Let's find x, y. So we just put this x. So x from 0 to 1 dx, right? Then for y, so for fixed x, y is from x to 2x dy. Then here x, y, then a over 3 xy dy. So just do this integration, right? So this integration is easy. Okay, so for this problem, also we need to determine covariance. So covariance, we need to do some calculation or find do some double integration. Okay, so what is the density function here? So density function, okay, so x is uniformly distributed on this 0 to 12. X from 0 to 12. So x is uniformly distributed from 0 to 12. So giving x equal x, suppose this x equal this line x equal x, y is uniformly distributed on this interval from 0 to x. Okay, so we know this region is just like this part. So we say this fxy during the density function is uniform is constant on this region, right? So this triangle region. So by now we can find this k, this c. So this we can easily find this c. So c, the total area c is equal 1 over total area. So total area is 12 times 12, half 12 square, right? 12 times 12. Okay. Okay. So by now there's a problem easy. Like, so let's say find the covariance. So we need the covariance x, y. So equal x, y minus x times y. So here we can, at first we can say x, y is same. So we just need to find x, and we need to find x, y. So what is x? So x equal let's say x equals this d, right? So x f x y. So this f x was constant. Suppose this equals c. So then x from 0 to 12 dx. Then y is from y from 0 to x. Okay, so for this integration, now we put it equals c. Okay, 0 to 12. So here integration about y is x constant, so this become x squared, right? x squared, yeah, x squared x. So this equal. So c. So here there's 12 squared. So this is c. Let's say 1 over 3, 12 squared over c. So c is half 12 squared, right? So we can easily find this x equal 2 over 3. So same way we can find x, y. So just the double integration. So for this problem, we want to find expected age, expected value, expected those things. So this age is what is this age? Age is just x, right? Yeah. So we just find x. So we have a density function. Join the density function, find the x. So such a problem is easy, right? So just equal this region, okay, x f so dx dy. Okay, so plug in here. What is x? So this region x is between 2 to 10. This is 2 to 10. Y is 0 to 1. So this part. Okay, so this problem become really easy. So equal 2 to 10 dx, and then dy 0 to 1. So x, then this density function dy. So such integration is easy. So for this one, we want to find marginal density function for y. So let's see what is the marginal density function of y. So this joint density function is in this region, y equal x, and y equal x squared. So y equal x squared is thus, right? Y equals x squared. So this line is y equal x. Okay, so we know the region this part. Okay, so we want to find density function of y. So density function of y is when y so between 0 to 1. So y, let's y fixed. So it is also all x. So density function is just the marginal density function of y is just the we let this y equal y, so this y can change. So if we fix this y, so just add those all this x, right? So we say f y. So actually, like here we just regard y is constant by now. So this is just 15y. But this y's range is from this point to this point. This y is for all those x. For all those x, so we need to add them up. So for all those x, okay, okay. So maybe we need to adjust this. Maybe multiply k, right? So what is k? What is k? K is we just make those integration to be total integration to be what is the marginal density function for y? Yeah, so x is fixed. Yeah, okay. So for this y, so the x is from this point to this point. So we need a mark. So what is k? So k is just like that. We say we let the k, so 12 y d, so all those dx at the y fixed. So it's x. So x from where to where? X from this y to square root of y. So we want to make this equal 1. Okay. So let's say, so this integration out is k times 15, so half y square, right? Oh, I'm sorry. So this integration is about x. Y is fixed. Yeah, so here be careful for this. So y is constant. So this is 15 y k times radical y minus y. Okay, so this equal 1. So we get k equal, let's say 15y radical y minus y. 1. Okay, so this as the function equals this. Plug it in. So this just equal radical y minus y over 1. Okay. So for such problems, so like for marginal density function for y is just we let the temporarily this y is constant. So x changing from added all those x. Okay. So for this one, let's say we want to find conditional values of y giving x equals x. We want to find this conditional values of y giving x is x. So we let x fixed. So we need to know the density function for this conditional y. Okay, so let's say, so here this is like x from 0 to 1. X from 0 to 1. So y from x to x plus 1. Okay, so the region this part, right? This part. Okay, so now for x fixed, not x equal x, then y from this y to this y, right? So we want to find this density function for this y. So let the x fixed density is such y. We also call this like this y equal. So we just plug in x like 2x. So we just plugging in x is fixed just like x. So just a 2x. So here x is constant fixed. So this is just equal a constant, right? A constant. So maybe this 2x is not do not make this do not make a density function. So maybe just multiply k. But anyway, like this is the constant, right? Constant about x. Okay, so this constant is just from x. So that's just from y, just from x to x plus 1 is uniform distribution. So we know this is constant c equal 1. Okay. Okay, so the variance is just the uniform distribution from x to x plus 1. So this variance just equal the formula 12. So this minus this, b minus a, right here, b minus a squared. So that's just 1 square, just the 1 over 12. So for this one, we want to find a covariance for that C1, C2. So actually C1 equals this. And C2, what is C2? C2 is size combined claim just after the application of the surcharges. So surcharge is 20%. So this actually C2 equal x plus y multiply 1 plus 20%, right? Charge more, so 1.2. Okay, so here we need to use this formula. We have this formula. So covariance for C1, C2. So this equal covariance of x plus y. So here 1.2x plus 1.2y. So here we have this formula for covariance formula. So equal, so we can say just like multiplication. So x plus y multiply 1.2x plus 1.2y, so equal 1.2x x. So this x is just vx. So plus xy 1.2xy or 1.2xy, like 2.4 xy. So xy is covariance for xy. So plus xy, yx, yeah. So then plus y is 1.2 vy. Okay. So we can find what is vx. We already know of vx. We have this zx and zx squared, so we have vx. And zy squared, so we have vy. Yeah. So how can find the covariance of xy? How can find this? So we from this condition, variance of x plus y equal a. So this variance of x plus y equal, we have this vx equal vx plus vy plus 2 covariance of xy. So we know vx, vy, and vz, so we can find this. So finally we can get the answer just by some simple math. Okay. Okay. So here let's say what is the density function for x? So what is this x? X equals this. Okay, right? The constant x is this. So the question is like we know density function for x and like t1, t2. Then we let x equal to t1 plus t2. We want to find its density. So such a problem is just we know x, we know this two variables. So we know x, y, then we find a new variable. So this new variables, that's the function. So for such a problem, for find the density function, we need to find the cumulative function, then use derivative. Okay. So for such a problem, we just want to find this. Let's say cumulative function equal this x less than x. Okay. So this equal, so plug in equal 2t1 plus t2 less than x. So for fixed x, we want to find this probability. And we regard this probability as a function of x. So this function is a cumulative function. So then use derivative, we can find the density function. Right? Okay, so now let's check this. So what is the distribution for T1, T2? Oh, so T1, T2 for have a density function z. So actually the exponential distribution, right? Okay, so by now the problem is easy. So T1, T2, so T1, okay, T1, T2. Okay, so we want to find let's say 2t1 plus t2 less than x. So this is this line. Okay, so we want to find the probability in this triangle. Okay, so let's say, so we can check, let's say for t1 first. Okay, dt1, dt1, so t1, so from so largest t1 we let t2 equal 0, so x over 2, right? So t1 from 0 to x over 2. Then for fixed t1, this t2 is from 0 to x minus 2t1. So dt2. So the density function, there's the density function of t1 is e negative t1, and e for t2 is negative t2, right? So dt2. So this is just we need to find this integration. Then regard this is a function for x. Then use derivative, we can find the density function. Okay. Okay. So for this integration, let's say here dt2. So we regard t1 as constant. So take this t1 to here. So then the e negative t2 dt2 is just e negative x dx, just the e negative x dx, right? So we can easily find this integration. So for this problem, it looks like quite the same. Like, what is the density function for this? So we need to find just the cumulative function first. So let's say we want to find this function equal probability that x less than x. Okay, so then let's check out what is x. The x denotes the ratio of cream to premium. So x equal cream over premium. So what is cream? So cream, let's check this up. Cream exponential, cream is for exponential distribution. So this, okay. So let's say, but anyway, like let's say, so x less than x equal Cream over premium, this less than x. Okay, so this equal p c less than p times x. We want to find this probability, right? So this c, let's see, c follow exponential distribution claim for exponential distribution with this lambda equal 1, right? 1 over lambda mean equal 1, 1 over lambda equal 1. So there's a p follow this exponential distribution mu, so that its mean is equal to pure mean. The mean is 2, so equal 2. So we need to find this probability. So we don't like C or P. Maybe we prefer use X, Y. Yeah. So we use X, Y, Z. We use X, Y. Okay. So now, so this one is like this. Let's see. We put this as, let's say, here is C, just like X. Okay, and Y. So here's P. So this X less than PX. So what is, so let's, so what is this region? C less than PX. So let's equal. So equal meaning this a line, right? So like C equal PC PX. So here X constant. Yeah. So when where is larger than? So here equals larger than. So this part, right? This part, like a y larger than x. So this part, yeah. So for this integration, we just say the by now easy, right? Equal. So we just change to x, y. So x from 0 to infinity. X. The density function also can, but density function is independent of the density function for x is just the negative x dx. Right? Then for y is from this point for fixed x, this y or this p is just equal. Okay, just like equal. Okay. So here, we should use a different notation, like because this x, this x fixed x, this is x is constant. So here we just maybe we use dt. Oh, so here just confuse. Okay, let's see. Maybe we should use like we use T or S. Okay. Oh, just P or C. Maybe we just use C or P. Okay. So here's C, D, C. Okay. So then here become from the Y. The P is from C over x, right? And infinity. So p dp. So not dp. So that's the function for p is p is for this exponential distribution mean is 2. So lambda is 1 over 2. So we just use, let's say, lambda 1 over 2 is negative 1 over 2p. Okay. So this problem is just like math problem, so we careful just those integration. So this equal 0 to infinity e negative c. Okay, c. So for this part, so just lambda is negative lambda x. So from this point to this, so this probability just like for exponential distribution. So this probability is equal e negative lambda a. So we can use this formula. Yeah. So this one integrated out is just e. So lambda here is lambda is negative half, and this here is c over x. So dc. Yeah. Okay. So here c is variable. So x is constant. So we just take this. So take out. So here's 1 plus 1 over 2x c dc, right? Okay. So this integration, like we use this negative lambda x dx, x from 0 to infinity is 1 over lambda, right? So that's equal. Final answer is 1 over SAS. Okay, so simplify. So multiply 2x, so that's equal 2x. So okay, 2x plus 1. So there's a cumulative function. Then find the derivative, so we get a density function. Okay, so this is two variable continuous two-variable continuous distribution. Okay, so we can stop here. Okay, so thank you.